I know I did enough Mondays. I worked accordingly because I planned on missing Tuesday. All right. So on the second page, again, we're just doing a series, but now we're doing a geometric series. We were doing arithmetic, where it was stop talking. So we were doing a series where when it jumped, you added the same amount every time. Geometric, it's multiplication every time. So you just use this formula. You can do a summation. You can write a summation and try to figure out the formula, but then you'd have to plug in the numbers 1 through 9, and that would take a lot of time compared to just using a formula. So we're trying to find S9, the sum of the series up to the 9th term. And so what's A1? Negative 12. Parentheses, and then you do 1 minus, what's R? The ratio. Is it 18 over 12 or 12 over 18? So negative 18 over negative 12 reduces to what fraction? 3/2. To the 9th power over 1 minus 3/2. So you can just put it straight in your calculator like that using your control divide key in your parentheses. So everybody put that in your calculator. So negative 12, parentheses, control divide, 1 minus 3/2 to the 9th. It's only the 3/2 to the 9th.
So, R is your rate of change.
R is your rate of change. Yeah. How far you're going in the. Yeah. And you're going to get a weird number. So what'd you get? And it's negative, right? I believe so. Got it? Oh, okay. That's it.
Okay, yeah, that's what I got.
Good. It's just your 3/2 that's to the 9th power. If you want to put parentheses, you can. You don't have to. All right, what about the next one? S? We're trying to find S what? Yeah, you can just leave it in fraction form.
Wait, but we're trying to find how come on this?
Now remember what summation means. Summation, if you have a sign right here, the summation sign, it means that end is just your starting number, and it goes all the way up to this end. Okay, so how do we find A1? Plug in plug in 1. Plug in this number down here. If this was a 3, you'd plug in the 3. So 0.3 to the 1 is obviously 0.3. So A1 is 0.3. Hello. Parentheses 1 minus. Yeah. Okay, now how can we find R? We could find A2, right? What would be A2? Good. It would be 0.3 to the second, and then you could take 0.3 to the second divided by 0.3 to the 1. Remember, your ratio is your A2 divided by your A1. So if you just take 0.3 squared divided by 0.3, what's it going to be? 0.3. If you do it on your calculator, you understand a lot better. Right, 0.09 divided by 0.3 is 0.3. And then we got 0.3 to the 8th. And if you want to, put that in parentheses, but you don't have to. The only time you have to is when it's negative. And so far, they haven't been negative. This is rounded.
Oh, wait, that's wrong. You're right.
You got it?
Yeah, that's what I got.
And if you want to write a reminder yourself, R equals A2 divided by A1. All right, read the story problem at the bottom. The word problem at the bottom. Story problem. That's the old way everybody calls them story problems because it's a story. Nothing's changed. Unfortunately, when you get out into life, these are life problems, right? These are what you're going to be doing. So first of all, how much did they pay in the first year? Well, they paid $600 a month. Okay, so how much did they pay the first year? Good, times 12. 72,000? I believe it's 7,200. I hope. That's the first year. So they're going to pay $7,200 for the first year, plus 7,200 times what percent every year after that. So this would just be for the second year. Now I'm going to show you something to help you figure out what the rate would be. Can I factor out a 7,200 out of those? So I could factor out a 7,200, and I'm really just multiplying by 1 plus 0.05. And this right here is your rate. So what's my rate that it's increasing that we're multiplying by? Is it 0.05 or 1.05? Oh, I thought you said 1.05. So my rate is 1.05. So it's really your percentage, and then you put a 1 on the front. Because you're adding in, you have to add this part to the 7,200 you started with to get the second year. So my rate is just, this would just be for the second year, 1.05. So use your formula, though, to get your S6. Because you're adding up every year. That was just the first year and the second year. Now we need to do.
Oh, no. You're adding.
Right.
Yeah. There you go. There you go.
So now just use your formula, though, with the 1.05 to the 6. Sometimes it's a shortcut. Really, the shortcut is your formula. I mean, because you could take 7,200 plus 7,200 times 0.5 to the second, and then the third, then the fourth, and the fifth, and sixth, get the answer 6 times, and then add them all up. That's a lot of work. So do this on your calculator.
I got 48, 973, and 87. Any other way to do it?
No, you use the formula. Yeah, you can do it year by year. You could do the first year, and then this is plus the second year. The third year would be this times this squared, and then this times this cubed, and then this time you'd have to do it 6 times. Justin? Justin? Are you right? Justin, do you really want to know or no? So you just do it 6 times. Like the third year would be squared, the next year would be to the fourth, to the fifth, to the sixth. Get each answer, add them all up, but that takes a lot of time. Yeah, but you have to do them individually. Like the first year, it's almost like you'd have to make a table. And then add all the table up. Right. It's not just, yeah. Oh, yeah. That's fine. All right, moving on. So the next, if you move on to 1-6, I believe you have to memorize all the ones on the last page. They're right here. The last page. The only one that's missing is like finding the case term. Remember that formula in the very first thing? It was finding the case term. If you go back to 1-1, it's in there. All right, so now, sometimes when you have a series and you add them up and you keep going on, we will. Yep. Okay, we keep adding them up, and we add them up forever and ever and ever. It's called an infinite geometric series. And sometimes it converges. It's called converging. It converges to a number. But sometimes the number just keeps bigger and bigger and bigger and bigger and bigger. So right here, we're going to investigate this, whether or not this is true. It says, will this have a finite sum? Meaning just a number. Like 1, 2, 3, 4, 5, just a number. It will. This one will. So I'll show you. So we're going to investigate. So what is R equal? Take 1/4 divided by 1/2. You get 1/2. Good. So R is 1/2. So we're going to use our formula. We're going to use this formula to find S5, S10, S20, and S50. So that's just doing what we just did, which is A1 is 1/2 times 1 minus 1/2 to the 5th over 1 minus 1/2. So put that in your calculator. That's just using the formula on the previous page that we just did. That's just using the formula on the previous page. So find out what that is. So I want you to do all 4 of those. Do that now. You're doing it. So take all 4 of those numbers and plug them in. You're just plugging them into the formula from the previous page. Not with a calculator. No, doesn't matter. Because we're not putting any angle measure in. I would change it to a decimal this time, just because you'll see, in this case, yes. And now he won't give you back the money. He stole his money. He won't give it back.
No, he reached in my pocket during the first period. I didn't even feel it when he took the quarter.
Oh, you still have the quarter?
No.
Did you spend it?
Yeah.
Oh.
I don't know how I didn't do that.
Somebody get the first one at least?
Did that, but
0.9.
whoa, I didn't get that.
Make sure you put it in right.
Oh, I did. So would you find out something?
Yes.
Put me in. I'm ready.
What?
You,
yep. That's good. Doesn't it I think S20 keeps repeating. And I think point 10 keeps repeating, right? Okay, do S50. S50, what'd you get? So, so what happens is when you get to a certain point, some of these, they just keep giving you 1 every single time. Like they keep giving you a certain number, 1 or 2 or 3 or whatever. All right? So this one's called convergent. So as n goes to infinity, Sn is converging to 1. We call that a convergent series. And if you would have looked at this closely, we would have looked at this closely, especially this particular one. They all don't turn out this way. What is 1 minus 1/2 on the bottom? 1/2. So what happens really to the 1/2? They cancel. So it's really just 1 minus 1/2 to the end. Well, if you take a fraction and you keep multiplying it more and more and more and more, it keeps getting what? Closer and closer and closer to 0. So really this thing right here converges to 0. So the whole thing converges to 1 minus 0, which is, that's where the 1 comes from. But you can just pick a really large number and put it in, and you'll get what it is.
So what if they just find the infinite sum of what it's called? The finite form?
Finite, the infinite sum. You can actually do the finite sum by taking a really large number, putting it right there. Yeah, or 100 or something like that. Sometimes if you take too big of a number, your calculator goes, it says, gives you an error, like it's too big. But no, 50 is not too big. 100 probably wouldn't be too big on this one. If it's converging to like 1, then it's not going to be too big. Okay, so this is called convergent. And let's look at this one. Does it have a finite sum? We're going to investigate because we don't know. Well, what's R? R is 2. 1 divided by 1/2. You flip and multiply. Okay. And so we're going to have Sn equals 1/2 times 1 minus 2 to the n over 1 minus 2. So this bottom number will just always be negative 1. So nothing really cancels out this time. So in this one, you can just jump to your S50, but what happens? Because you're really just trying to figure out, as n gets bigger and bigger and bigger and bigger, what is our thing doing? What's our series doing? What's our sum doing, I should say? So as n gets bigger and bigger and bigger, what's our series doing? Good. So what do you get here? You should get some humongously large number. Are you sure? I got 5.629 times 10 to the 14th. I got 5.629 times 10 to the 14th. Say it again. Oh, okay. Just change it to a decimal. Okay, then hit. All right. And you can just hit Control Enter as well to get your decimal. So we get this humongously large number. So what do you think is going to happen if we do 100? Will it even do it? See if it'll do 100. And if you want these numbers, this is like 15.5. It starts out small, and then it's 511.5, and then it's 524 times 10 to the what? So here we get what? times 10 to the 29th. So if we just keep making this n bigger, this number is just going to get bigger and bigger and bigger. So is it converging to one number? No. So this is called divergent. Divergent. Because that means it's not converging to one number, and it does not have a finite sum. And then I would try just another bigger number and see if it keeps getting bigger. Because sometimes if it gets smaller, then you have to go the other way and figure out what it's doing. Because what if it was getting smaller? Yeah. Probably not. Yeah, this one's as good. So as Sn, or as n goes to infinity, Sn goes to infinity. Good. So as n goes to infinity, Sn goes to infinity, so it does not have a finite sum. And here's how you tell. If your r is between -1, I think I'm pointing it the wrong direction. Yeah, I am. You need to listen to this last part. It's the most important before you go. If the r is between -1 and 1, it will be convergent. But if r is like bigger than, or less than -1, or r is greater than 1, it will be divergent. So this one will go to infinity. So if our r is like -5, it'll be divergent. But if the r is a fraction like -3/4, it'll be convergent. That's always true. For geometric series, because that's what we're dealing with. So go to the next page. So 0.6, will that be convergent or divergent? If the 0.6 is, this is the r, because that's your formula. This one will converge because r is 0.6. Because this is the formula for a geometric series. This is A1, this is r, that's your formula. So this one will converge, so you go ahead and use those. See the formula at the top? If it's convergent, you use this formula to get your infinite sum. So just go S equals, yep. But this is probably the easiest formula. Because your formula for a geometric series is A1 times r to the n minus 1. Got it? So the A1 is 4. This is A1 right here. And you should get 10. Okay, what about the next one? What does r equal? You can either take 3 divided by 2 or 4.5 divided by 3, either way. What is it? 3/2. What's the decimal for that? Which you can see right here is 3/2. 4.5 over 3, because you should be able to divide this, divide this, divide this, and every time you should get 1.5. And you should check it to make sure it's a geometric series or a sequence. Like if it's not geometric, then it would be NA or unable to determine or something. So you should always check and make sure that this divided by this is the same as this divided by this to make sure it's indeed geometric. All right, so if my r is 1.5, is this divergent or convergent? It's divergent. So can we find a finite sum? No, because Sn will go to what? That's me this time. All right, it's my fault. I forgot to put it on silent. All right, and then 5, what's r? Oh, they really want to talk to me. Maybe not. Yeah, you don't. All right, for real? No. Okay, so divide those. Find your r. You take A2 divided by A1 or A3 divided by A2, and that should be the same number. Find R. You should get negative 2/3. So is this convergent or divergent? This one will converge. So you use your formula at the top. So what's A1? 2. You're right. Over 1 minus R, which is negative 2/3. Yep, exactly. It's going to be 1 plus 2/3. 2 divided by 1 plus 2/3. What do you get? 6/5, which is 1.2. Either one is fine. The fraction is fine, or the decimal is fine. There's 5 of these, and then there's that Kate's term one, which is like that. I think so. It's like your n, and then your k minus 1, and then your a to the n minus k minus 1, which is pretty much just the difference between those two, and then b to the k minus 1. So this is the Kate's term for a plus b to the n.
What is that on?
Like if I give you a plus b to the n, something like that, and I say find the 12th term, like that. With this, you can also use, I'll show you. This, you can also use Pascal's triangle. You don't have to use that. All right, let me stop it.